No single ant leads the colony. No single bird controls the flock. Yet somehow they move with incredible coordination. And today, artificial intelligence is beginning to learn the same principle. Welcome to the world of multi-agent systems. Imagine trying to coordinate thousands of independent entities. Each one sees only a tiny part of the bigger picture. Each one makes its own decisions, and none of them knows exactly what everyone else is doing. At first, that sounds like a recipe for chaos, but surprisingly, some of the most efficient systems in the world work exactly this way. From transportation networks and logistics systems to robotics and artificial intelligence, complex behavior often emerges without a central controller. And that idea lies at the heart of multi-agent systems. When artificial intelligence first emerged, the dominant idea was simple. Build one intelligent machine. One machine that knows everything. One machine that makes all the decisions. Most early AI systems followed this centralized approach. All information flowed to a single system, and all decisions came back from that same place. It worked, but it didn't scale very well. As computer networks grew, researchers began asking a different question. What if intelligence didn't have to live in one place? What if multiple systems could share information and work together? Instead of one mesh solving everything, many systems could contribute to the solution. That simple shift changed everything. At the center of every multi-agent system is something called an agent. An agent is simply an entity that can observe its environment, make decisions, and take actions. A self-driving car is an agent. A warehouse robot is an agent. A drone can be an agent. Even modern AI assistants can be viewed as agents. No matter how different they look, they all follow the same basic cycle. They perceive, they decide, and they act. Not all agents are equally intelligent. Some are reactive. A reactive agent simply responds to what's happening right now. Think of a thermostat. If the temperature drops, it turns on the heater. If the temperature rises, it turns it off. Simple, fast, effective. But some agents go much further. A self-driving car doesn't just react. It predicts, it plans, it evaluates alternatives, and it chooses actions besides on future goals. These are known as cognitive agents. A single agent can be useful, but many real-world problems are simply too large for one agent alone. Now imagine dozens of agents, or hundreds, each with different information, different capabilities, different perspectives. When these agents start working together, something interesting happens. The system becomes more capable than any individual agent. This is where multi-agent systems become truly powerful. Of course, collaboration doesn't happen automatically. Agents need to communicate. They need to exchange information, coordinate actions, adapt to changing situations, and sometimes even negotiate with one another. Without communication, you simply have many isolated agents. With communication, you get an intelligent collective system. Interestingly, this idea is becoming increasingly important in modern artificial intelligence. Many researchers believe that the future of AI won't be a single super-intelligent system. Instead, it may look more like a team. One agent performs research, another writes code, another reviews the results, and another coordinates the entire workflow. Each agent specializes in a specific task. Together, they solve problems more effectively than any one agent could alone. The future of intelligence may not belong to a single machine. It may emerge from networks of autonomous systems working together, systems that communicate, coordinate, adapt, and learn, from individual intelligence to collective intelligence. That's the journey we began exploring today, and it's the foundation of multi-agent systems. Multi-agent systems are no longer just a research topic. They are becoming one of the key ideas shaping of the future of artificial intelligence, and we have only scratched the surface. In the next episode, we'll dive deeper into how intelligent agents think, decide, and work together. If that's something you'd like to explore, subscribe and join me as we uncover the technologies that are shaping the future. I'll see you in the next one.